So I wanted to provide a little bit of homework help for lesson 1-7. So I'm on pages 70 and 71, and I've selected just a sampling of problems here. So let's just get right to it. Problems 3 and 4, we're supposed to find the coordinates of the image after the rigid transformation. So they're going to give us the coordinates of the pre-image, and then we have to do the designated transformation and then come up with the coordinates of the image. You do not have to graph these, you just have to come up with the coordinates. So letter A wants us to give us the coordinates of the image after a reflection in the x-axis. Okay, so remember in our notes, a reflection in the x-axis is really just going to change these y coordinates to their opposite sign, opposite number. And so the reflection would be x prime would be -9, -4. Y prime would be -9, +3. And z prime would be -1, +3. And that's all you have to do to show a reflection in the x-axis. The x-axis is going to change the y coordinate. If we did a reflection in the y-axis, that would change the sign of the x-coordinate of the pre-image. We did letter B under number 3 in your notes, so if you're not sure about that one, you can go back and check your notes and see how we did that. So let's just jump over to number C. If we do a counterclockwise rotation of 270 degrees about the origin, so we did a little illustration about this. What does this 270 degree rotation do to the ordered pairs of the pre-image? Well, they switch, first of all right, so you do definitely switch, but then we're going to change the sign of this new y coordinate. After the switch, then we'll change the sign of this y coordinate. So that means for x prime, so you can look at it this way. You just switch these. The initial switch would look like this, but then we're going to change -9 to +9. So switch and then change the y. Y prime, same thing. We're going to switch x and y. So if you have to do it in this order, just to make sure you catch it, but then we're going to change the sign of the y. And then z prime, we switch, and then we change. All right, so pretty easy. That will be the coordinates of the image after this particular rotation of 270. All right, let's do number 4. And this is a parallelogram, and these are our vertices. And so now let's do each of the transformations. So letter A says to do a reflection of this parallelogram in the y-axis. So that's going to change all of the x-coordinates to their opposite. All right, so P prime, I'll change colors here. We could say P prime is going to be +2, 5. Q prime is going to be +9, 5. R prime is going to be +9, -1. And S prime will be +2, -1. Okay, to do a translation, we add -3 to each of these x coordinates, and then we're going to add +1 to each of the y coordinates to come up with our coordinates of the image. So P prime is going to look like this. -2 plus -3 is -5. And then 5 plus 1 is 6. So that'll be P prime. Q prime, we start here, -9 plus -3 is -12. And 5 plus 1 is 6. R prime, -9 plus -3 is -12. -1 plus 1 is 0. And then I'll squeeze S prime down here. -2 plus -3 is -5. and -1 plus 1, of course, again, is 0. So that would be the coordinates after this translation according to this vector. And then a rotation of 180 degrees about the origin just takes each of these pre-image vertices, and we're just going to change both of the signs. So this will be the effect. All right, so P prime after this rotation will be +2, -5. Q prime will be +9, -5. R prime will be +9, +1. And S prime will be +2, +1. So each of the signs should have changed to their opposite. Just double checking and make sure. So it looks like we're good. And so that's the final answer for all three parts of problem number 4. All right, I have number 5 here, and let's take a look at these instructions are to identify the type of rigid transformation. So our rigid transformations, of course, that we're talking about in this lesson are translations, reflections, and rotations. So let's see what we got here with number 5. We definitely have a translation because this shape basically maintains the same shape. It's just being shifted from one location to another. We could say the slide, it was slid from down here in quadrant 3 up to quadrant 1. So we definitely have a translation. We could also say that we have a rotation because if we were to turn this around the origin, this would actually be a 180-degree rotation. We could turn it from green to blue, for example, or from blue to green. Turning it around the origin would produce this same shape, so we have a rotation. And then there's really, the most common reflections are over or on the x-axis and the y-axis, but there's also, we talked about these in class, there are also reflections around 2 other lines, and I'm going to point these out to you. One of the lines is called y equals -x. That's just goes right through the origin and has a slope of -1, so that's y equals -x. And its counterpart would be going the other way. This is y equals +x. Just think of a diagonal line that goes through the corners, the opposite corners, if you will, of the graph. So this is y equals x. All right, so you got to be on the lookout for reflections over x, over y equals x. That's this diagonal line, and then y equals -x. Well, in this particular case, we have a reflection over y equals -x. We could pick up the green and pick it up and set it down on the other side of y equals -x, and we would have the same shape. So this particular problem has all 3 transformations. All right, and you're going to get more into, especially this line y equals x later in math, because it's a really important line when it comes to a topic in Algebra 2 called inverse functions, logarithmic functions. You'll see that again, but it's good to go ahead and get a taste. That is a common line of reflection that shows up in math. All right, let's see what else we got. I've got number 10. The directions here, we're supposed to find the coordinates of the figure. So this is going to be our pre-image. We can go ahead and plot these points. 3, 9. It's going to be vertex A. 3, 7. Vertex B. And 7, 7. That'll be vertex C. I need to get vertex B out of the way. All right, so once again, we have this little triangle. All right, and now we're supposed to come up with the image. So this is the pre-image, and now let's come up with the image. So to come up with the coordinates, this is a translation, so you can go ahead and this is like moving none to the right or left. This is the left-right movement, and this is going to be the up-down. But we got to come up with the coordinates anyway, so let's just go ahead and use the math. So we're going to add 0 to the x, and we're going to add -4 to the y. So our A prime point will be 3, 5. B prime will be 3, 3. And C prime will be 7, 3. We'll plot those points. There's A prime. So essentially, this vector told us to shift this shape, this figure, 4 units downward. So you should be able to tell that all the points went down 4. Okay. And finish this little shape. It's kind of crooked, but that'll be all right. Okay. We'll finish this off. This is B prime, and this is C prime. And that's all we have to do on number 10. We have to graph the image, the pre-images in blue, and the image, and identify the coordinates. All right, we got another one of these here, just a different transformation. So let's go ahead and plot point M is -7, -1, -7, -7. Sure. Yep. And then -1, -4. Connect those. All right, and then we're going to do a reflection in the y-axis. So it's like picking this red shape up, picking it up, flipping it over the y-axis, and then setting it down on the other side. So to get the points of the image very quickly, we just change all of the x-coordinates to their opposites. So M prime will be 7, -1. P prime will be 7, -7. And R prime will be 1, -4. All right, so a flip over the y-axis means we change the x's. So let's do 7, -1, 7, -7, and 1, -4. And it illustrates the flip. I'll just go ahead and label. So this was M, P, R, R prime, M prime, P. Okay, that's number 11, and got one more of these. Let's do a rotation problem. So this is the pre-image, -5, -4, -2, 0, -2, -4. So there's our pre-image before the transformation. X, Y, Z. All right, and to do a rotation of 270 degrees counterclockwise, that means we're going to switch these ordered pairs, and then we're going to change the y to its opposite. So x prime is going to be that. Y prime, we switch the ordered pairs, and then change the y. And then z prime, we switch the ordered pairs, and then we change the y. All right, let's plot these. -4, 5. 0, 2, and -4, 2. It's in blue. Right. And so I'll just go ahead and label these. This is x prime, y prime, z. All right, looking good so far. I got a couple more, and then this has to do with that figure down at the bottom. We're supposed to identify the type of rigid transformation performed. For example, to get from NMP, let me just highlight that. To get from NMP to CJD. Well, hopefully you can tell that it wasn't just strictly moved. That would be a translation because you can see it's been turned. It wasn't, I guess you could say that the thing about number 14, it might be a little tricky for some. Some people might be tempted to say that this is a reflection. It's definitely not a translation. We said that earlier, but notice how the order of the letters, that's a key component to this, because this says that N is mapped to C. All right, so in other words, point N would go where point C is. M maps to J, and P maps to D. Okay, so to be a true reflection, these should pick up and they would sit down, and N and C would map together. M and D should map together, but you see how these are switched. So that tells me that it can't be a reflection. So you got to be careful there. I know it looks like it would be. So what this is going to be is a rotation. So if you spin this around, you can kind of tell if this were to spin around sideways, if you can kind of visualize that, that's going to push this, as M rotates around, it's going to fall down here. And as P rotates around, it'll be the last point that come around, it'll fall here. So you just have to be careful in cases like this and map the letters together. And so our final answer for number 14 is going to be a rotation. All right, and now let's take a look at number 16. CBJ. Oh, CBJ. And NQP. Okay, now this is going to be a reflection because C maps to N. All right, so C would go to N. B, in other words, if there is a vertical line going straight down, we pick up this shape and flip it over, which is what a reflection means. We flip it. Then B would map to Q. And J, if we flip this over, would map to P. So this side, in other words, when it's picked up and flipped over, would lay down right here. And so the letters would correspond at that point. So this is going to be a reflection. All right, I think that's all I have for you on this homework help video. So I hope that helps. And if you need any other help, come see me, and I will see you next time.